così mi guardo. Lì c'è la webcam attiva.
Sì.
Devi guardare diretto nella webcam.
I think the metallic body of my MacBook. Wow. Okay, finally we can start. So, welcome everybody. I will just give you a couple minutes to introduce you to what Pisa.dev is and what we are doing here. I'll let also Leonardo present the Google developer group of Pisa, and then finally we'll get to our amazing speakers for tonight. We have 2 different talks. I just want to ask a couple of questions. For how many of you this is the first event of Pisa.dev? Okay. We have a bunch of new people. I'm really glad we have. And how many of you are students? Maybe here at university? Okay. A lot of students. I think, so when I think of these communities, I remember my first time taking part of one event similar to this one. It was from Google developer group here in Pisa while I was a student here in this very building. And it was, I think, the Google I/O of 2016. It was their first event ever. It was just born. And I realized later in my life that taking part in these events, taking part in communities was such a great choice for my career. I met a lot of new people. I discovered a lot of new stuff, new interests. Even if maybe you're not that interested in the topic our speakers will talk tonight, I hope not. It's great. It's great for sparking new interests. And maybe even you don't understand 100% of what's being said during the talk, but you take home some keywords, some stuff to Google and to increase your curiosity. And that's just great. And this is why we are here tonight. This is why I started Pisa.dev and all other contributors out there that makes this event possible. And that's basically it, all I have to say. I just want to add that we are almost 1 year in Pisa.dev. Next month, in July, it's officially the first birthday of Pisa.dev. Very happy. And we will share some event, I hope, a little bit different from our usual events. So please be sure to subscribe to our newsletter. You can find it on our website, which is Pisa.dev, I guess. It's easy to find. And also join our Telegram group, is where all of our community lives, actually. And for example, today we had like one person wanted to learn some Go and getting some useful answer. I think so, because I answered it. I was asking for resources to learn Go, or we have other people talking about web development and stuff. We could also use more different topics like IoT. I would love to hear somebody involved in the IoT world. We don't have many of those. That's it. Take part in our community. If you want to help and become a contributor, an organizer of these events, just ping me, let me know. It's great. You can meet a lot of new people, talk with speakers coming from all over the world, like this evening. And it's really amazing. You can be even more involved, and it's really satisfying when you give back to the community something. That's all I have to say. I'll leave Leonardo with a little. Okay. I'll leave Leonardo presenting the Google developer group.
Hello, everyone. So I'm Leonardo from GDG Pisa, Google developer group. And as Antonio said, I'm in pretty much for the same reasons as him. We like community, we like events. I'm not even a programmer. Like, I do that as a hobby. That's not my life. So I just like the tech community and everything around it. And I met a lot of people while doing this. So yeah, it's great. Just a short bit about GDG. GDG is a global community. We have a lot of chapters, they're called. There's a GDG in in Rome, there's a GDG in Pisa, one in London, as one of our speakers today will will tell us. And there's actually more than one in some cities. GDG is a Google community. We are basically sponsored by Google. We are not Googlers, so we don't work for Google. We are developers, mostly, even if just for hobby. And we are mostly a group. Again, what Antonio was saying is that we like to group. We like to do group stuff. And that's pretty much the most of it. I won't take any more time since we are already running out, I think. But yeah, everything else, we are trying to hold this first event together as GDG Pisa and Pisa.dev, because when Pisa.dev was first starting out, we had a discussion talking about what kind of people we were catering to. GDG Pisa has always been more of a university stuff. Like, we try to appeal to university students, and I'm glad to see a lot of you here. Pisa.dev was more focused on professionals, and also there were a lot of hands raised before for students, but there was pretty much half of them down, so I think that's great for them as well. And so yeah, today we are trying our first joint event, hopefully bringing something to both of the groups, and hopefully trying to make the people of the two communities join the other one as well. Okay, can we call on the first speaker?
Yes.
Emanuele, can you please join us? Do you have any slides you want to show, or do we just connect in person? A small round of applause for Emanuele.
Devo connettere qualcosa? Se vuoi, allora ti condivido io questo tra. In teoria vediamo.
No, uso questo.
Esatto, tu proietti. Se ti va bene. Forse però non è nitidissimo.
No, va benissimo così.
C'è solo albero di sotto, magari.
Non mi piace molto, però non è nitido.
Lo puoi nascondere?
Guarda com'è sfruttato.
Era suo.
Ho succato. Se lui si attacca direttamente il tuo computer.
Quindi tu, se non crea danni, sì.
Crea un pochino di danni, però facciamolo così.
Proviamo.
Dovrai solo staccare la condivisione dello schermo e riconnetterlo. Hold on a second. We are streaming on YouTube, and of course there are all sorts of problems. Usual. Spero che abbia
Just as a double check, people in the back, can you hear us properly with the microphone? Is that fine?
Great. Si vede? Su video però ricondividi lo schermo, se no non lo schermo.
Vediamo se... Sì.
No, dentro. Facciamo questo.
Sì, no.
Credo vada bene. Sì, io vedo che sta condividendo. Facciamo il microfono. Vai, ci siamo.
Okay, very good. Setup was not that difficult, and I mean, we made it, so that's already an achievement. As Antonio said, if you will get bored at any time in this presentation, please consider that it's full of cute cats. So just wait for a few slides and it should get better. Today we are talking about GitHub Copilot. So GitHub Copilot was launched 2 years ago in a technical preview. I should not stand here, sorry. It was launched 2 years ago in a technical preview, and in a quite limited time range, it achieved some astonishing results. On the first month after the technical preview ended, the first month of paid subscriptions, more than 400,000 people paid 10 euros a month to use GitHub Copilot. As of January 2023, more than 1 million developers were using the tool every day in their workflow. These numbers were shared by Microsoft CEO in the quarterly earnings call, just to underline how important this tool is for the company. And in these 1 million developers, they're not just students and professionals in the early stage of their career. There is also some superstar in the software engineering community. For example, the very creator and benevolent dictator for life of Python, Guido van Rossum. This quote is taken from a recent interview Guido gave with Lex Friedman, and it's pretty interesting to understand what is the benefit that Guido gains from Copilot. He says, I use Copilot every day. It doesn't save me a lot of thinking. It just automates the boring stuff for me. We will get back to this point in the future. However, Copilot is a tool like everything else. It can be seen as something revolutionary, and it probably is, but if we see the bigger picture, it can also be seen as just the latest step in a trend that is decades in the making. For instance, at the very beginning, it was IDEs, then it was the rise of Stack Overflow. Now we have GitHub Copilot. The pattern is pretty clear. We are developing more and more tools to take the repetitive and boring work off the shoulders of the developers, trying to automate it, trying to have some machine perform these tasks for us. Good. As Copilot is probably just a tool, we need to understand how to use it properly. In order to get the most out of it, we should, however, answer 3 basic questions. First, how does Copilot work? What really happens when we see the suggestion popping up in our IDE? Second, what are the main benefits of Copilot? If 1 million people use it, it must be some good. Third, what are the problems with Copilot? Since its introduction, it was not just praises and applauses for it. Legal actions were threatened against Copilot. Actually, one is ongoing in the United States. The United States Committee of Professors warned that the extensive use of Copilot can damage students in high schools and in universities. And researchers and cybersecurity experts warned about possible vulnerabilities introduced by Copilot itself. So we want to dig a little bit deeper. And to do that, we will start by analyzing how Copilot works. So first thing first, usually Copilot and Codex are used as synonyms, are used to indicate the same thing. Well, they are not the same thing. Copilot is a complex system based on Codex, which is a large language model. It's the same family of GPT-3, which is fine-tuned to work at its best in generating code. So this is a picture from the very first technical preview of Codex. Codex derives from the GPT-3 family, but it's actually smaller than GPT-3. GPT-3 has 175 billion parameters. Codex has just 14 billion. Does it mean that it's worse? No, it's just more specialized. So people at OpenAI took a reduced version of GPT-3 and fine-tuned it first on 159 gigabytes of Python code, and then they used other programming languages as well in order to make the model aware of the syntax, of the pattern, of the idioms of many different programming languages. So how does a large language model work? I mean, it could take hours to discuss that, but in just a sentence, I would say that a large language model is a black box that takes some text as an input and generates some text as an output. For the model, the output is just text. The model does not have any deterministic rule to say, okay, I need to generate some code, so I must respect the syntax of the programming language. It does not work that way. So it can, in theory, and even in practice, generate code that it is not syntactically correct. And of course, it can generate code that it is not semantically correct. That means that it does not what the programmer wants it to do. However, thank you to extensive training on a very large amount of publicly available repositories, Codex has learned how the most common programming languages work. So it is very likely that it will produce code that it is syntactically correct, and we will see how likely it is that it produces code that is semantically correct. Very good. Now, this is Codex, and this is Copilot. So this is a system diagram taken from a blog post from Copilot itself. It was released in May 2023, so it's very recent. It's probably the Copilot you are using on your machine right now. How does it work? So it has two main modules. The first one is on your local machine. It is a plugin of your favorite IDE, Visual Studio Code, PyCharm, you name it. And the second module runs on Microsoft servers in the cloud. In the first module, what happens is that while you type, the plugin scans the file that you're editing before and after the cursor. Earlier version of Copilot just used the code before the cursor. We will discuss about this change in a few minutes. The most recent versions of Copilot also scan all the open files that you have on your tabs of the IDE. So if you open 5 tabs and you edit just one, of course, Copilot is scanning also the other 4. Again, earlier versions of the tool did not have this feature. We will see in a moment why it was introduced. With all this text, the modules on your machine uses some heuristics, some rules of thumbs, to create a prompt. A prompt is the text that works as the input for the large language model. It creates the prompt, and then using the prompt itself and some data about how you reacted to previous suggestions by Copilot, it decides whether it is worth to send the prompt to the module on Microsoft servers or not. So that's why you only see suggestions in specific points when you type specific lines of code. It's not that every time Copilot can generate a suggestion, it does. It must first overcome the filter of these heuristics in the local module. Then it comes to the large language model on the Microsoft servers. There is an API call. There is an API response, of course. And the response is basically your suggestion. The large language model does not generate only one output. It generates many, like 100 of them. Then, out of these 100 outputs, just a few get sent to your local machine, the ones that have the highest probability of being created by a human being. Of course, these probabilities are outputs of the large language model, and they are used to sort the generated text, the generated code, in order to provide you with the most likely suggestion. Of course, using shortcuts on your keyboard, you can decide which suggestion to accept, and you can decide whether to accept the suggestion or not. The idea of taking both the code before and after your cursor and all the code in your open tabs is just to create a better context for the large language model to work. Large language models are very sensitive to prompts. That's why prompt engineering is so hot right now. And the idea of scanning such a large number of files, such a large number of modules, is just to give as much context as possible to the large language model in the cloud. That's why it's an experimental feature, it's not yet released, but GitHub Copilot is working in embedding a vector database inside the plugins. Vector database is just a collection of embeddings for specific bunches of text. So you take a bunch of lines of code, you embed them into a dense vector of real numbers. It means you transform them into a dense vector of real numbers. This vector in its metric space should capture the semantic meaning of the code. So the idea is that if two vectors are close in their metric space, their meaning is similar. And when you type code, Copilot does not only scan the file that you're editing, does not only scan the file that you're open, it scans your entire code base, comparing vectors, and then it embeds the vectors that are most similar to the ones relative to the file that you're editing into the prompt. So this way, the context gets expanded from one file to a bunch of files that are open in the IDE to your whole code base. Good. Not good. Very well. Now, we have described how Copilot works. Does it work? Does it work well enough? Well, according to GitHub itself, the answer is yes, unsurprising. They're making a bunch of millions out of this. So this is again taken from a blog post from GitHub. I will share the slides. You can, of course, check all the sources. In a survey conducted over 2,000 developers, GitHub found that Copilot makes them 55% faster when they're coding, 75% more satisfied of their work, and Copilot is writing 56% of the code. Fun fact, the percentage, of course, varies a lot across different programming languages. The most verbose and the most common result in the highest percentage. You can guess what the top performance is on percentage of code generated by Copilot. It's Java, of course. Well, these numbers are pretty impressive, but they don't tell the whole story. I mean, you can write code extremely fast, but if it's not correct, it doesn't really matter. You can be very satisfied of what you did today, but if in 2 months you end up discovering that you have lost a bunch of data in production because of the code you wrote today, well, you will not be very happy in the future. So this is perception. This is not a scientific proof of the goodness of Copilot. It is worth checking a little bit deeper where does this perception comes from. But I'm already running out of time, so I will just say that the conclusion here is the one that Guido was giving in the very first statement into the slides. So Copilot makes developer happier and more effective and more efficient because it automates the boring stuff. Basically, it takes care of the boilerplate code, it takes care of the for loops, it takes care of the things that you would write without thinking. But it does not do good refactoring, it does not do good system design, it does not do good software engineering. This is still on the human side. Now, does Copilot write correct code? The answer is sometimes, not always. This is a chart taken from the OpenAI technical report about codecs. It shows that the standard GPT-3 is very bad at writing code. You can see the blue line, which stays at 0. It basically writes code that it is always incorrect, while the other lines scale quite well with the number of parameters of the model. What are we measuring here? Well, guys at OpenAI created a bunch of tasks that could be solved writing Python functions and created unit tests to check if the created functions were correct. This is the percentage of unit tests that were green. So if you see 0.4 here, it means that Copilot is capable of generating 40% of solving 40% of the tasks correctly, generating 40% of the function that really do what they need to do. Contenders here are, well, GPT-3, Codex, and another version of Codex that uses a different version of fine-tuning. Doesn't really matter. What matters is pass at 1, min log p, and oracle ranking. These are different ways the output is produced. Of course, large language model can generate different outputs, and they are more diverse to each other depending on the temperature, which is an active parameter that you can set from outside. Pass at 1 means take the first output and evaluate the model on that output. Min log p ranking means take 100 outputs and take just the one that has the highest probability of being generated by a human being. Oracle ranking means generate 100 output, and if one out of 100 is correct, then we can say that the output is correct. A little bit cheating. Yeah, and you guess it, Oracle ranking is the violet line.
Excuse me, which is the prompt that is given to the model to write this function to be tested? You give them the unit test, you give them one default description of the syntax.
This one. Okay. So the prompt is the description of the task.
Okay. Thank
you. Okay. However, Codex is not so great. It's not so amazing in writing semantically correct code, but these large language models are getting better and better. So this 38% was the performance of the Codex model that was used in the first version of Copilot. GPT 3.5, which is the backend large language model of ChatGPT, the free version, achieves 48% in the same test with the same setup. So we give them the task, he writes the function, and GPT-4, the latest model by OpenAI, goes up to 67%. Bear in mind that GPT-4 was not fine-tuned on code. So this is the plain version of GPT-4, the one that you can access through the APIs or through ChatGPT with the premium plan. Very well. And then there is the smoking gun, if I can borrow some words from George Bush. GitHub performed a randomized experiment. So they gathered a bunch of developers. They said they were all proficient in JavaScript. They assessed it before the experiment, and they split the developers randomly. 45 of them were allowed to use Copilot. 50 of them were not allowed to use Copilot, and they were given the same task: write a JavaScript web server. The task is considered completed if it has a bunch of basic features that were described in the task, and if all these features were correct. They were tested by human developers from Copilot, from GitHub. Sorry. Here the numbers are pretty are pretty astonishing. 78% of people allowed to use Copilot completed the task against 70%, and they completed it in 70 minutes against 2 hours and 40 minutes. So more than a 55% improvement in time spent. However, if we read the fine print here, we can see that the variance of the experiment is pretty large, and it results in confidence intervals that are quite wide. I mean, still the improvement is statistically significant, so this 55% has no reasonable chance of being 0, but I mean, the uncertainty is not small. You can see from 21 to 89%. Good. Now, it looks like Copilot does work, does help developer in being more effective and efficient. What's the dark side? Every new technology has one. Copilot, of course, is not the exception to the norm. But before digging into the real problems of Copilot, let's get one out of the way. Is Copilot a stochastic parrot? So does it just recites what it learned by heart? Hell, no. Guys from GitHub performed a very large-scale test here. They analyzed 50,000 plus suggestions that were collected while people at Microsoft were working on using Copilot. And they found that Copilot just gave 41 pieces of code that were exactly identical to some code that was found on GitHub in the training set. So 41 out of 400,000 plus. So it's 0.009%, quite negligible. Okay, however, there is some dark side in Copilot which has to be taken seriously. This is a study published on an IEEE journal about the security in Copilot's suggestion. In this study, the researchers just asked Copilot to generate code for, let's say, 1,600 tasks, so a wide range of tasks, and they checked the code that Copilot was generating using a static checker. So they tried to understand if in this code some patterns of insecure software were evident. The answer is that there were pieces of insecure software, and about 40% of the generated snippets contain vulnerabilities. Okay, 40% is a lot. It means that basically, I mean, it's almost like a coin flip. You can get either secure or insecure code as you flip a coin. That's not great. But the point is that if you run the same tests on code from GitHub, so open source code, and snippets from Stack Overflow, you do not get different results. I mean, the percentages are almost there. And it makes sense because Codex was trained on code from GitHub. So it has no idea of what is secure and what is insecure. It just has the idea of what is likely to be generated by some human. So what is on GitHub? So the numbers should be there. However, there is something annoying, because by digging a little bit deeper, by analyzing the individual snippets, researchers found that the one most important feature predicting whether Copilot was about to generate insecure code or not was the presence of insecure code in the code base. So the idea is, if you're creating some code in a code base that already has snippets of insecure code, Copilot is more likely to generate other insecure code. That's annoying, Because if you are an amateur developer or a junior developer and you trust Copilot, you're most likely to be in trouble. But there's more. Here is a research by Stanford based on a randomized experiment. So again, they took a bunch of, well, students because they were easy and cheap to hire. They could be blackmailed with credits or something like that. And they asked these students to solve some tasks. It's always the same story. You solve some tasks, but these tasks were specifically designed to be prone to insecure code. So they were basically traps. They were trying to make students fall and write something that was not secure. And they did it. And the point is that the students having access to Copilot were far more likely to generate insecure code than students that did not have access to Copilot. Because they were over-reliant and they were trusting too much the machine. So the point is that if you find some code on Stack Overflow, at least you check it. At least you say, who knows who wrote this one? Let me try and spend a few minutes understanding if this is correct or not. If the code is suggested to you by Copilot, it's almost as if it was suggested to you by the IDE itself. So it has to be correct, right? Well, no, it does not have to be correct. It does not have to be secure. And the results of the experiment were pretty clear. People using Copilot were far more confident in the security of their code, even if their code was far more likely to be insecure. The last paper I want to talk about is from OpenAI itself. So this is the paper introducing Codex. This is from 2021, a couple of months before the technical preview of Copilot was presented. And there is one piece of this paper which is very interesting. This one. It says that Codex will generate code that is as similar as possible to its training distribution. That makes sense. That's how large language models are trained. They're trained to generate the most likely text as output. If the user has some subtle mistakes in their code base, Codex may deliberately suggest code that superficially appears good, but it is incorrect. Again, that's a model that is trained to generate the most likely output. If you're writing buggy code, the model says, we are writing buggy code, aren't we? I will do the same. And you're basically in trouble. This is exactly what the researcher from the iCycle paper found out. It's exactly the same phenomenon. Very good. Now to the last point of this talk. How to use Copilot. We saw how it works, we saw what are the benefits of it, and we saw what are the dangers. So just to recap, it works very well. It does help in automating boring stuff, but it's not a replacement for human thinking. People should put effort in understanding if the suggestions of Copilot are correct. They should put effort in putting them into the bigger picture of the software project. So, first guideline. In education, use Copilot to understand code, not to generate it. Because if you're not an expert in generating code, Copilot is most likely to generate code that is likely to be generated by an amateur. So it's not going to push you forward in your learning path unless you push it to do this for you. How can you do that? Well, most likely not using Copilot, but using the more advanced tools that are going to be published soon. Copilot X, for example, has a special feature where you can ask questions about the code in natural language. So that's very interesting for learners. Second, Copilot does not replace proper testing. Again, it's a probabilistic model. It has no idea of what you're trying to do. It just generates the code that most likely solves your problem if you've written the prompt correctly. Or it generates the code that most likely fits into your existing lines. And who knows if that's exactly what you wanted. So some deterministic rule to understand if the code generated by Copilot is correct or not have to be there. And Copilot, of course, does not replace code reviews for the same reason why it should not be used by, it should not be used in a widespread way in education. You need some human judgment to understand if that piece of code is the best one, if it is secure or not, if it really solves your problem in the most effective way. Final. As of now, there is no tool based on generative AI that is proficient in software engineering and in system design. These tasks are still only for humans. So don't push the tool to do something that it was not designed to. Just use it to write basic algorithms, functions, classes, or even better, portions of classes and portions of functions. That being said, I'm Emanuele Fabiani. I'm the head of AI at Extreme. We are a small company in Milan, 15 people, and we use AI to solve business problems for scale-ups and corporates alike. We specialize on tabular data and time series forecasting for the most part. I'm also very keen at participating in conferences. I was traveling around Europe in the last few months. I talked at ODSC London, AMLD Lausanne, in Wrocław, in Poland, and so on and so forth. It was a real pleasure being here, and I hope that this talk was useful to you as well. Questions? No questions? Okay.
Just more than a question, or maybe comments. Because in your slide there is a data that for me doesn't add up. So the model Copilot has been built to replicate the training.
Mm-hmm.
Clearly with some caveats, but it's a replica of what is being. I found really strange that your slide where you said where they evaluate citation, the rate is so low. I don't expect this kind of behavior from a tool that should do that.
You mean the 38%?
No, the 0.009%.
This one?
Yeah. That's, for me, it's very surprising.
Well, it's not that different from the behavior of any large language model. So they're not trained to create sequences that are exactly identical to the ones they wrote, they have seen in the training set. They are trained to replicate the same patterns. I mean, they are trained to complete words and thus to create patterns that are similar overall to what they saw, but not identical. I mean, this 41 is relative to, I mean, is based on relatively long sequences of code that were exactly identical to other sequences seen in the code base. I'm not saying similar, I'm saying exactly identical. So the most obvious example that was actually taken out of the 41 is the GNU license. I mean, if you start typing the first words of the GNU license, Copilot will complete with the whole license. And this makes sense, because every time you type these words, you're probably typing the whole license. But when you write code, it's pretty uncommon to write exactly the same 20 lines of code over and over again, unless it's some automatically generated code or some very clear pattern. So that's the reason of the 41. It's because it's only the exactly identical long sequence.
Just to understand, let's try I ask the tool to generate a swap.
Mm-hmm.
Reword the swap of an array that things that every one of us wrote like thousands of times. Normally, we usually use X and Y. So if the tool generated with Y and Z, it's not a recitation.
Yes.
Okay. So okay.
That's the point, exactly. I mean, if on GitHub the name, I mean, it's a string-to-string comparison. So if on GitHub the names of the variables are different, that's a different piece of code.
Okay. So let's say if in Java we evaluate the bytecode, for example, that number is reasonably higher.
Yeah, it may be. I mean, for the details, you can check out the procedures, the procedure they used in the blog post. But yeah, it's an exact string match.
Okay, this makes sense.
I also read that this matrix of exact recitation is silly because it could be 90% of almost identical code, semantically identical code. I was interrogating myself on it is good or bad to have a lot of semantic recitations in a sense. So it is bad if it has a lot of code that is already written, or if its purpose is to write code, little snippets of code that are already written a lot of times, and so you can trust them. So
the point is that Copilot was created to overcome the limitations of code generators and suggestions that are already implemented in your IDE. So if it just suggests you code that it is, I would say, deterministically correct because it has to be that way, it would be useless. So it was built not to do that. And I would add just one bit to this one. It's not written there. It's just my interpretation. So it may be completely wrong, but I have a feeling that this blog post was written by Copilot to protect from the accusation of just copying open source code. So they had all the interest to keep the figures low.
I think it's not bad to copy open source code in general. If I want a swap, I could just have the same old swap copy pasted from everywhere. So
yeah, this is perfectly okay, but this is a well-known algorithm, and there is basically one way of writing it. They had a legal action against them because they were accused of copying open source code.
Yeah, because it's not written in the license that you can use for publishing this web.
Yeah. I don't know. I mean, they say that they did everything following the rules. People say they didn't. It's hard to tell.
I don't think Salman would be happy.
Yeah, like for GPL, we have of course there aren't any laws on AI generated stuff in general. I think.
I don't think so. I mean.
So that's kind of the point.
Yeah, that's the point.
GPL wise, you can't use the fact that it's on GitHub because it's still under
Yeah, it's under copy.
So from a Stallman point of view, I don't think it's.
But
Okay. I'm sorry to stop this.
We can talk during the dinner. I want to say just one last thing. If you have any kind of feedback about this talk, please let me know. You can find me on LinkedIn. Just write a direct message, and I would be very glad to hear your feedback, both positive and, of course, negative. Thank you very much.
Mi serve per l'entry. No. Un po' di mare. Ah, ok. Allora, aspetta, come lo faccio? Che come faccio uscire? Sai la comprendita? Ah, giusto. Ah. No, questo proiettore, scusa, come fa uno a trovare il mouse? Ecco. Questo già. Sì, volevo portarla un attimo giù. Oh, ecco. Ecco, fatto caso. Vai un po' più sotto qua. Così. Poi dovresti avviare un po' più. Sì. Ho il touchscreen e poi condividere solo la proiettore. Questo? No? E si condivide. A Windows. Se vado bene. Sì, perché ti vedo.
No, faccio veloce. Quanto mezz'ora? No, 20 minuti. No, anche meno, mezz'ora. Tanto l'avevo programmato di fare anche la demo, ma la demo normale.
Dove ti metti? Qui?
Ah, perché mi devono vedere?
Sì.
Allora metto qua. Sì,
Come
dai.
no?
Round of applause, please.
Oh.
We are applauding the fact that we were able to make the projection.
Yes. It's amazing technology. Can we ask ChatGPT to make a better projector, please? Okay, so welcome everyone. My name is Alessandro Puccetti. I work for a company in London called Hack Industries, and I used to live in London, and now I'm back in Italy, and I hope to create many more events on cloud technology with the GDG Pisa people, and hopefully after this talk, I will share a QR code that you can scan and share your feedback on what kind of cloud technology topics you would like to see in future events, and so we can tailor better new events to the feedback. So feel free to share this link to everyone that you know, friends, colleagues, or that are not even here maybe. And hopefully we will have many more events together. So a bit of background on myself. I am a former Pisa alumni of computer engineering. I did some research in network security and privacy in some university overseas. And then I worked in a company in Germany on Linux technologies, did a bit of contribution on systemd that I'm super proud. So there is some code in systemd that is mine, and I'm very proud of it. And then now I work for Hack Industries as a, let's call it, principal data platform engineers. Mouthful, but kind of do all the data platform needs. In this talk, we're gonna go through these things that we had in our company. We had to automate a bunch of data pipelines, and we start using a product called Composer, but it was quite expensive for the use that we were using it. And when Google released this new product that is pretty much a serverless orchestration tool, we were able to really cut the cost and have an incredible performance increase by switching to this new technology. Okay, so this is a quick outline of my talk. I'm gonna show as Cloud Composer, which is the tool that we were using before, just to give you an overview. And then I'm gonna present the workflows and how they're different to each other. We're gonna go through the cost saving and performance improvement that we had. I will do a quick announcement that I already previewed. Bit time of Q&A, and if the time allows, a quick demo of workflows. So, Cloud Composer. Cloud Composer is a fully managed tool from Google that is based on a project that is called Apache Airflow. If you don't know, if you're not familiar with it, it's a Python-based open source project that allow you to create and code workflows that are called DAGs, direct acyclic graphs, that allow you to pretty much code any type of sequence of action that are depending to each other, condition. The only thing that you cannot do is create a cycle in this. So go back to the start and create kind of a loop or a for loop or stuff like that, as the acyclic mean in the name. So this is just to give you an idea that is pretty beefy things to use. When you deploy Composer, it's a few clicks or a few Terraform lines. It's super quick and easy, but the behind the hood is huge. You have a part that you cannot even access. It's completely managed from Google, is the blue part, and the red part is instead the one that you can see in your project, so in your environment. And you interact with the UI, you can see how the tasks are performing, to deploy new tasks and things like that. However, there is a lot of moving parts. There is a SQL proxy, there is storage, there is a database, a bunch of scheduler that need to run continuously and keep scheduling tasks and stop if something upstream fail and ask for what to do next and things like that. So there is a lot of process going on, even if you're just handling a simple task that could be send an email or run this query, get me the result, and send it to a bunch of people via Slack or whatever. So you can run very simple DAGs. This is how they call it in Airflow. So you have the beginning. So this one, for example, will wait for the first three to end, and then we'll be able to execute. And in the also run these can execute whenever it's ready. And the last one, of course, we have to wait for everyone to be completely successful to be able to run. But also you can write very, very much complex DAGs that you can pretty much not read or fit in the UI. So it's very powerful. So we encounter an issue that in a previous talk that I did in London, I called the short-living task annihilation, because pretty much took down the entire Composer infrastructure. It was kind of unable to use it anymore, because we had this specific use case where we run a daily task to provide data to our clients and to our internal stakeholder, but every now and then we had to rerun all history. So imagine that you have a 7-year history, multiply 365, multiply probably like 10 versions of the data. And you can imagine how many million of tasks you have to, you end up running, and you want to do it in a timely manner. You don't want to wait like a year to do it. And so we were in the situation where we were running hundreds and hundreds of tasks at the same time in parallel, and this made the overhead of scheduling and managing these tasks so high that the complete system went to a halt. I like this screenshot of, it seems like a lot of tasks are doing no work and completely freezes your laptop. So all the XP users maybe remember this. Younger generation don't. Thank God for it. Okay, so entering the scene, workflows, they call it just workflows. It's very confusing. But. So what this product is a very simple, to the point way of scheduling and managing and orchestrating different services that are not running on anything that you own. Because in the previous solution, the composer also has workers like actual VM that you can write code that execute locally. In this case, you just glue together different pieces of code and application that run somewhere else. And so the scheduling, all the stuff around the orchestration is super simple and very fast. You can connect to all the Google Cloud APIs and service, of course, but also on third-party APIs. So you could connect to Amazon, you can connect to the weather API and get some data and use them to do something. So it's very flexible. You can run very simple tasks, workflows. That in this case, it creates a table in BigQuery. If you don't know what it is, we're gonna have more events about it. I really like it. I use it all day, every day. We export the table and then we save on GCS, which is like a storage solution of Google. So pretty simple. But also you can write very complicated one that have condition. If this happened, then do this, or otherwise do another thing, do for loops, parallel things, like you can define a piece of, not code, because we're not gonna use code here, piece of configuration file that can then run in parallel. Seems magic. But in fact, like you don't use a programming language to write this workflow. You use JSON or YAML. And what you do is just define a sequence of steps that you want to do, checks that you want to validate. You can do for loops because there are keywords that are defined are identified as a as a loop, and then they are compiled into the Google infrastructure black magic and then running whatever language they wanted. That I don't know. The caveat here is that your interface is very limited, so you can perform very basic and extremely limited computation locally. So you cannot say, oh, I have a do map reduce with Python, all this kind of stuff. It's pretty much just arithmetics, some string regex matching and things like that. And then also you have only 512 kilobytes of variable space in your workflow. So you cannot say, oh, I'm going to load this 500 gigabyte CSV file and do something with that. It doesn't work like that. Ooh. Okay, but for us, it was the perfect match because the 99% of our workflows were simple gluing together different things happening in different parts of Google services. So running query on BigQuery, exporting the data, copying it somewhere, send a table to a customer, copy the data to S3 from GCS or things like that. Things that you can achieve with different services. With services that are that provide the logic for you or the computation for you. You don't need a machine and write a lot of code that say download the file, upload the file, stuff like that. So when you have to orchestrate things that look at a service that are run somewhere else and then provide you just an interface with the data or interface with the action you want to provide, it's a great solution. But I mean, the talk was save bank, so we're going to save some money or not. Otherwise, we're talk for 30 minutes for nothing. So let's see the performance and the saving that we had. So the daily job execution is for us is 10 times faster than before, because now it just takes the amount of time of the task that needs to do the work that it needs to do. So run the query, takes 5 seconds, it takes 5 seconds. Not doesn't take 5 seconds plus the scheduling, plus the logging, plus the scheduling, plus a bunch of other stuff. So we cut from 30 minutes for this particular type of task to 3 minutes. When we, for example, for the multi-year daily execution, instead the performance is even greater, pretty much because you can run more in parallel. That's the only reason. Instead of taking me like a month of babysitting the cluster and rerunning failed tasks or things like that, I was just kicking off in the morning, and when I off home in the afternoon, it was finished. So instead of a month, it took like 8 hours of work, not work, like just running time was an actual work. Yes. And what about the cost? Because something that's so good, it might cost like it's a huge amount. Usually it's like that. But for us, actually it was very cheap, because the Cloud Composer cluster to run has to have a lot of these processes, the SQL database, worker, VMs, all the kind of stuff. And so it was costing us about $900 a month just to keep running around at the very minimum load. And instead, workflow, you pay only for the steps that you do. So if you do, I don't know, a sum, you pay for that sum. If you call BigQuery to run a query that takes an hour, you just pay for one, because you did one thing. It doesn't matter if it takes an hour, it doesn't matter if it takes 1 second. And so the daily cost for us was, we didn't have a daily cost. We just had this $900 a month. And now it costs just $1 to run daily and $70 to run the entire history of all our data versions. So a little announcement. As I said before, if you are interested to know more about cloud topics, you can fill up this Google form. I will be happy to have more feedback and more idea on what bring in the next events. And if you have any question, I'm here.
I know absolutely nothing on cloud development.
Yeah.
So I want to ask, you had to migrate from Dalla,
Yes.
your system to what? Was it a painful migration? Because the new workload you said has less feature and simpler.
Yeah, for us, it was, for me, I did this. It was actually quite easy because the nature of the workload that we had, they were literally just call a service, do something, and so the code matched one-to-one pretty quickly. We didn't have to implement a lot of logic, and so that was also actually reduced the size of the code base, and actually for me it made it much more readable because there is less fluff around. It just you read and you understand what's going on. It's not like that you have to look at a function that does this or that. It's very to the point. But this probably is an edge case of our work, of our use case. I don't know if it's generic like that, in general like that. So, yeah. And I don't know if we have time. I could try to swing this live demo against myself, because it's not ever a good idea to do a live demo, but I like it dangerously. 10 minutes tops, hopefully. 5? 5, okay. 5, let's do this. Okay, so as I told before, so this is a workflow. So you can see it's written in YAML, and this is on the console, on the UI console. I will connect to an API that I found that give you back jokes, and then I will translate then the jokes in multiple languages using the Translate API of Google. So what I did first, I create I made the API in a secret. That is this other product called Secret Manager. You put secrets there, you can read them, and you can set up access control, this kind of stuff. But the good things is that you don't have to code the secret anywhere. You just access, you say, okay, give me this secret from my own project that is called like this. And workflow will call, we make the API call to get this secret and put it there if you have the permission to do it. Okay, so you can see like, I mean, I find very easy to read, but tell me if I'm wrong and if you have any question. I also put a parallel statement just to make it a bit more interesting, even though, you know, translate for language is not going to be breaking the bank on time. So let's see. On this tab, I can call the workflow. Of course, you can call through the API, a bunch of SDK library, just easier this way. I'm going to say, okay, what type of joke I want? I want regular jokes. And then I want the jokes to be translated Italian, French, Spanish, German, Portuguese, Arabic, and this is Chinese. It doesn't. Okay, so finally. Okay, execute, runs, bam. Okay. So you have the joke. There was Santa keeps his suit in the closet. Okay, I don't know. Doesn't sound very funny. And then you have it in Arabic and all these other languages. I wanted also to send it to our Slack, to our Telegram channel, because it would be cool to have all these jokes sent to the channel, but I didn't have the time to connect it. But you actually can, because at work, I just send a bunch of alerts on Slack, and pretty much the same idea. Without breaking the chair. So, yeah, that's it. And the cool things for me is that all these translations were called in parallel because of this keyword. What does it mean? That all the steps here are executed in parallel through the list of arguments that you pass in this array called languages. And for when you run, for example, query that takes hours, is very useful. In this case, not very much, but it's just for example. Okay, so I hope you enjoyed, and you will share your experience on the forum, so we can create a bit more events for you. Yeah, sure. Good.
Per chi ha preso il biglietto